of reactions. We looked at synthesis or combination. That's when we take two or more things, combine them together for one product. Right? When we looked at decomposition, when we take one thing, breaks apart into many. And then the last thing we looked at was combustion. And we did that prac last week, right? So two different types of combustion. One is complete combustion, right? That's when we've got a bountiful, right, supply of oxygen or excess oxygen. When we have limiting oxygen, it changes the products. So the products end up being carbon monoxide and water. Complete combustion, the products are always carbon dioxide and water. All right, so now I'm going to look at acid reactions or reactions of acids. And there's four main types in which we can break those down. So, first one is acid plus a reactive metal. Now, not all metals will react with an acid. But acid plus a reactive metal will give us a salt and hydrogen gas. Now, hydrogen gas is H2. Right, so we've got to think about that when we're balancing. When we refer to salt, right, it's really an ionic compound, right, not just sodium chloride. Yeah, gents? Thank you. So a salt in general refers to an ionic compound. And what that does is that it takes the metal, becomes a metal ion, and it takes the anion, right, the negatively charged ion from the acid, and that is what our salt will be. Acid plus a metal hydroxide gives us salt and water. Acid plus a metal oxide gives us also salt and water. And an acid plus a carbonate gives us salt, water, and carbon dioxide. So there are four main reactions of acids.
So what would the general definition of acid be?
There's not one reaction of acid.
No, but like, how would you describe?
Okay, I'll pause that. Okay, so let's look at these four examples in a little bit more detail. Acids reacting with metals gives us salt and hydrogen gas. So hydrochloric acid plus magnesium as an example gives us magnesium chloride and hydrogen gas. So this was one of the mini experiments that you did last week. Yeah, and that would be balanced. So hydrochloric acid, HCl. It's a common acid that you should know. Other ones is nitric acid and which is HNO3, sulfuric acid, H2SO4. Right, so there are three common acids that I would expect you to know, and I'll write them on the board as well. Acid, nitrous acid is actually something different. It's HNO2. When we think about it, often students use the word dissolving for the magnesium, but metals themselves don't dissolve, right? Because it's actually reacting with the acid, not dissolving in the water. It's the ion of the metal that will then dissolve. Okay? So, important distinction. Acids with metal hydroxide, often referred to as a neutralization reaction. So that's pretty important. What does the word neutralize mean? To balance or to cancel out. So if I take an acid and a metal hydroxide in stoichiometric proportions or equal proportions, right, they will balance each other out so that the solution is no longer acidic or basic, right? And it would be, if I did that accurately enough, it would be safe enough to drink. Yeah? Wouldn't taste very nice. Tastes like salty water. Yeah? So how we actually get, you can actually create your own salt and vinegar flavoring by taking bicarb soda and vinegar. You react them, right? The remaining salt is called sodium ethanoate. You boil the water off and you take that sodium ethanoate, you can sprinkle that onto your chips, and that's how you get salt and vinegar chips without being soggy. And so notice that like I was talking about, the anion, right? So the negatively charged ion within the acid is what the salt will be. So hydrochloric goes to a chloride salt. Sulfuric goes to a sulfate salt. Nitric to nitrate salt. Phosphoric goes to phosphate salt. Ethanoic acid goes to ethanoate salt, often called acetic or acetate. Anyone seen the movie Fight Club?
Yes.
Yeah? So there's a scene in Fight Club where he puts lye, right? Lye is sodium hydroxide solid. Okay, and what we do, it's a very, very strong base. It's fairly stable as a solid, but it's called hygroscopic. And what that means is it absorbs moisture from the atmosphere. So in this scene, right, the Brad Pitt character licks Edward Norton's character's hand, sprinkles the lye, the really strong base, and that starts to eat away at his skin. And this, what we do to mitigate that is to neutralize it using a weak acid like vinegar. And so this, don't know if you can see it clearly, is a photo of my leg from when I was your age. I was 16, I spilt potassium hydroxide onto my leg. So here is, it looks big on here, but the key is there for reference size. It's about the size of a 50-cent piece. I've got a permanent scar on my leg from spilling potassium hydroxide onto my leg, working at KFC. So yeah, there you go. Safety is really important. I wasn't wearing an apron, right? Potassium hydroxide, bases are really good oven cleaners. So I spilled oven cleaner onto my leg, didn't do anything about it. It ate away at the skin went black, had to wear betadine and redress it for several weeks. So, acids with metal oxides. Like with hydroxides, same products are produced as hydroxides. The difference is that hydroxides often will be a solution, could be a solid, but often a solution. Metal oxides are generally insoluble. So metal oxide as a solid reacting with an acid gives us our salt and water as well. So an example there, sulfuric acid plus copper oxide gives us copper sulfate and water. Acids and metal carbonates, right? Our last reaction type. Sulfuric acid plus zinc carbonate gives us zinc sulfate plus carbon dioxide plus water. We can test for the presence of carbon dioxide using what's called the lime water test, right? So if we extract that gas and if we bubble that gas through lithium hydroxide, which is lime water, lithium hydroxide, is that the carbon dioxide will react to form a lithium carbonate insoluble solid, which is why it appears cloudy. So our test for hydrogen gas is the POP test. So if we were to light a flame over this reaction, the flame would extinguish owing to no oxygen present, right? The carbon dioxide would extinguish the flame. Whereas if we bubble the carbon dioxide through lime water, right, we get that solid precipitate forming. So we know it's carbon dioxide. If we bubble hydrogen gas, it remains colourless. So we've got to think about many different odourless and colourless gases are produced in chemical reactions. We need to consider what type of tests that we need to do to establish what that gas is. There's your classic example. Vinegar and bicarb, all of those bubbles are our carbon dioxide forming. Okay, and that's the end of, we want to be able to write both word and balanced chemical equations for those four key types, considering those 3 or 4 main types of acids to know as well.